The IMSECH function within Excel allows us to find the result of applying a hyperbolic secant operation on a complex number. Now the formula itself is quite straightforward. We simply type IMSECH, and so this will return the hyperbolic secant of a complex number, and all we have to provide is the complex number. So in column A, I have a bunch of complex numbers, which consist out of a real and an imaginary part. The part with the I is the imaginary part. You could also substitute I for J. That's mostly done in electrical engineering. Now, I close the parentheses, I press enter, and I will be pulling this down. And there we have the result of the hyperbolic secant of the respective complex number. Now, a secant is actually the inverse of a cosine. Now, we could also get the same result by dividing 1 by the hyperbolic cosine of this complex number. Let's give that a try. So, in order to do this, we will have to take the hyperbolic cosine of this complex number, and you can do this with the function imcos(h). So, I write imcos(h), and I supply the complex number as the only argument. Now, I need to divide 1 with this number, and we cannot use simple division for this because complex numbers are considered as text or string. So we need special Excel functions to work with these complex numbers. And so what we're looking to do is to divide 1 by this number. So we use the function imdiv, which allows us to divide 2 complex numbers. So the first number is simply 1, and the second number is whatever was returned by the hyperbolic cosine function. I close the parentheses, press enter, and I will be pulling this down. And as you can see, the results we're getting are matching exactly with whatever we got from the hyperbolic secant function. Now, one thing you might not be entirely aware of is that the hyperbolic cosine of a complex number is actually the same as taking the cosine of this complex number multiplied with I. That is quite fascinating, so let's give that a try and see if we are actually getting back the same results. So what we need to do is to multiply our complex number with I. Once again, we cannot do this with a regular asterisk or a multiplication because these complex numbers are text and not numbers. At least that is what they are considered in Excel. So for this, we need to use the mProduct function, which allows us to multiply multiple complex numbers. So in this case, we want to multiply I, so I put it in between double quotation marks because it's considered as text. And then the second argument is the complex number. Now I close the parentheses, and of this number I will be taking the cosine. Now because we are working with a complex number, we need to use the special function imcos function, which will return the cosine of a complex number. So I close the parentheses again, and now we have to divide 1 by this number. So just like before, use the imdiv function, and then the first argument is 1, and the second argument is whatever was returned by the cosine of the complex number. I close the parentheses, press enter, and I will be pulling this down. And as you can see, we are getting back exactly the same number. Now, one thing you might not be aware of is that the hyperbolic cosine is actually defined also using Euler's number, so using exponential functions. So the hyperbolic cosine is equal to e to the power of the complex number plus e to the power of the negative of this complex number divided by 2. And if we then divide 1 by this number, we will also be getting the hyperbolic secant. So let's give that a try. So Euler's number is of course 2.71828, etc. So we can write the exponential function using e to the power of z, but we can also use a function for this within Excel, which is the mexp function. So what this will do is it will take e as the base and bring this to the power of the argument that we supply. So in this case, I will be using the imexp function. And so the argument will of course be the complex number, which we can find in column A. And so then we want to add this to another number, right? So for this, we need to use the imsum function because we cannot use regular mathematical operations because you already know complex numbers are considered as text within Excel. So then we need to use another imexp function. But this time we need to take negative of this complex number. So first we need to multiply this complex number with -1. So we use the mProduct function for that. And so we multiply -1 times the complex number which we find in A2. Okay, so now I close these parentheses and I close them again and I close them again. So what we're now doing is taking the sum of e to the power of z and e to the power of -z. Okay, so now we have to divide this by 2. So I use an imdiff function, which will divide this by 2. And I will wrap this in another imdiff function, which will take 1 and divide it by this number. Just like that. I close the parentheses and press enter, and I will be pulling this down. And as you can see, we are getting back exactly the same results. Just some different possibilities on how we can calculate a hyperbolic secant. Hopefully they give some insight as to how the hyperbolic secant is actually being calculated. Of course, if you ever need to do this, the easiest way is using the IMSECH function within Excel. You simply supply a complex number and out comes a hyperbolic secant. Thanks for subscribing and leaving an optional tip. Consider watching this video next.